Okay, here's problem set 2, which was on 1020. And for number 1, you're given this lovely function. And it's asking you to find the distance to the nearest hundredth of the two zeros that are closest to each other. So what you're going to do is go to Desmos and you're going to graph that lovely thing right there. So 4x to the third power minus 5x squared minus 23x plus 6. You're going to look at these zeros right here, and you're going to tell me what is the distance between the two zeros that are closest to each other. So I have 0.25 in the middle, I have 3 at the end, and I have negative 2 at the beginning. So from negative 2 to 0.25, that's 2.25. I also have 0.25 to 3, which is 2.75. So your closest distance would be 2.25. Number 2, you're trying to find the intervals that matches up with this lovely graph right here. So looking at, let's say, negative 4 to negative 1, I could see that my interval is positive. Looking at negative 2 to 0, I could see that it is decreasing. Looking at 0 to 2, I know that if it's in brackets, then it's probably going to be negative. How do I know that? Well, at 0, you have negative 3, and then at 2, you have some negative number. Yes, it is increasing, one might say, but it's negative because of the brackets. Remember that increasing, decreasing intervals do not have brackets. And then from 0 to 4, you are increasing, which makes sense. So from 0 to 4, you are increasing. Number 3, which of the following has x minus 2 as a factor? Select how to apply. And I gave you a little hint to do not factor. Use the remainder theorem. So if you're using the remainder theorem, you're going to plug in x for 2 for a, b, c, and d, and your y value has to be 0. For x minus 2 to be a factor. So once you do that, it's going to turn out that a and c would be your two factors that has x minus 2 as the factor. Okay, number 4, a polynomial equation with your coefficient has roots of plus or minus 1 and x is equal to 2i. What's the minimum degree of the polynomial equation? Well, I know that it's going to be more than 2 here because of the plus or minus 1. And then because of this 2i, I also know that imaginary roots come in pairs. So I also need to think about the minus 2i. So I have plus or minus 1, plus or minus 2i. That gives me 4 total roots. So my minimum degree has to be 4. H of x is dashed below, and the function g of x is unsolid, and it's on the same graph. Which statements are true? G of x has a lower minimum, so that is true because g of x is my solid line. For all values of x, h of x is less than g of x. So h of x is my dashed absolute value, and this is not true for all values. It looks like it's going to be greater than my solid absolute value. And then last one, for any value of x, g of x is not equal to h of x, which is true because looking at this, you could see that it's just a translation, so you know that your lines are going to be parallel. And if they're parallel, they're not going to intersect at all. So that was problem set 2.